Hello guys, welcome back to a new video. In this video we'll be talking about latent heat. Now what if I told you that ice and water can both exist at the same temperature? This might be strange, but yes, they can both exist at the same temperature. How? Now let's say you are trying to melt down some ice. Okay, this is ice and you are trying to melt down this ice and eventually turn it into water. When the phase change happens, when you see that the water is turning into liquid, or into when you see that the ice is turning into water, this is where both the ice and the water are going to have the same temperature, 0 Celsius, and water also will be having 0 Celsius. This is called what? This, guys, by the way, not to confuse it, we are not saying that if you continue heating up this liquid, it is going to still be 0 Celsius. No, we are talking about the phase change. When this ice is going to change its phase, it is going to have the same temperature as the liquid, okay? But when you see that the ice is melting down, the temperature is still 0 Celsius. What happens is basically this. What happens is that the molecules of the ice are going to be broken down, okay? And new forms of bonds are going to be formed between the molecules of the liquid. So if I ask you, what happens during the phase change? You will say that the temperature or the bonds are going to be broken down and the temperature is going to still be the same. The energy needed to break down these bonds is called latent heat. So if you define latent heat, you'll say what? You'll basically say it is the heat energy used or needed to break down the bonds between the atoms of the molecules without raising the temperature of the substance. Or you can say the energy per unit mass that is transferred during a phase change of a substance. This is basically from the equation that we are going to learn in a minute. What is phase change? Phase change is basically when a substance changes its state from one state to another. For example, solid to liquid, or ice to, or for example, solid to gas, or gas to liquid, which is condensation, and etc. Potential energy increases with the distance of the particles. So if the distance of the particles is increasing, potential energy is going to increase too. We have two types of latent heat. The first one is heat of fusion, and the second one is heat of vaporization. If we define them very simply, we will say heat of fusion is the energy required to turn solid into liquid, or vice versa. You can say liquid to solid. Okay, this is the energy required to change solid to liquid or liquid to solid. Heat of vaporization is what? It is the energy needed to turn liquid to gas or gas to liquid. Okay, so you have two types of latent heat. We have heat of fusion and we have heat of vaporization. Heat of fusion is what? Is solid to liquid or liquid to solid. Heat of vaporization is basically the energy required to transfer or change the phase of a substance from liquid to gas or gas to liquid. Now, how can we measure latent heat? We have an equation. Heat is equal to mass times latent heat. If we are dealing with heat of fusion, this L is going to be L sub F. If we are dealing with vaporization, then this is going to be L sub V. Okay, this is for heat of vaporization. If we rearrange this equation and we want to find latent heat, this is going to be what? This is going to be, divide this by M, cancels, and latent heat is going to be heat divided by mass. And you know that heat is measured in what? In joule, and mass is measured in what? In kilogram. This is what? This is the unit for latent heat, both heat of fusion and heat of vaporization. Now we have latent heat for the following, or fusion and vaporization, of course, for some common substances. We have water at 0 Celsius. The heat of fusion is going to be 3.33 times 10 to the power of 5. This is basically the energy needed to break down the bonds of ice, okay, or water. We have heat of vaporization for water, which is equal to 2.26 times 10 to the power of 6. You don't have to memorize them. I'm sure it's going to be given when you are dealing with problems. Now we have this question. It says how much energy is removed when 10 grams of water, so we have our first given, mass is equal to 10 gram. Okay, change it to kilogram, it's going to be 0.01 kilogram. Okay, mass is equal to 0.01 kilogram. Is cooled from steam at 133 Celsius to liquid at 53 Celsius. So we are going to do what, guys? We're going to calculate Q total, okay? Heat total. First of all, we're going to find out how much energy is needed to for steam to cool from 133 to 100. Then we are going to find the heat of vaporization for steam to condense to 100 Celsius. Then we are going to calculate the heat needed for liquid water to cool from 100 Celsius to 50 Celsius. First of all, let's do steam to water. Okay, we have Q1. Okay, Q1, because we have two temperatures. Okay, we have the final F and we have the initial. Okay, so we are going to do what? We're going to subtract them. Okay, when the temperature is constant, we are going to use the equation we just studied, which is latent heat of vaporization and of fusion. Okay, but if two temperatures are given, as you see here, 133 and 100, you're going to calculate both. So Q1 is going to be what? The same equation we studied for CP. Okay, CP times mass times delta T. You might ask, CP of what? Okay, CP of steam, of course. Okay, so we need something. CP of steam is going to be equal to what? 2010 joule per kilogram per Celsius. Okay, and you already, this is what? Steam, sorry. And you already know CP of water, which is equal to 4,186 joule kilogram per Celsius. Okay. Now, this is used for what? This is when two temperatures are given. When the temperature is not constant. When the temperature is not constant, you are not going to use the equation for latent heat. You're going to use this equation, okay? Now, this is going to be equal to what? Q is going to be equal to 2010, which is the specific heat capacity for steam, times mass, which is equal to 0.01 kilogram, times delta T is going to be what? Delta T is going to be 133 minus 100, okay? 133 minus 100, okay? 133 minus 100, okay? Calculate all of this, and you get what? You get 663.33 joule. This is the first Q. Okay, then we have Q2. Okay, now, as you see, let me erase this one. As you see here, this is 100 Celsius, okay, all of this. It's a straight line. There is no change steam condenses to form liquid. Okay, at 100 Celsius, there is no change in the temperature. So you might have guessed what equation we're going to use. We're going to use latent heat of vaporization, okay? Because this is gas to liquid, okay? So M LV, L sub V. Now, what is the LV, which is heat of vaporization, is equal to what? You can refer to the table. It is equal to 2.26 times 10 to the power of 6 joule per kilogram. Okay, and we had mass. Just plug in the values and that's it. Mass is equal to what? 0.01 times, and we have what? 2.26 times 10 to the power of 6. Q2 is going to be what? Q2 is going to be equal to 22,600 joules. 22,600 joules. This is Q2. Okay, we have the final Q, which is Q3, which is going to be equal to what? Again, look at this line. Okay, it is what? It is declining. Okay, from 100 Celsius to 53 Celsius. Again, we have two temperatures. So we are going to use what? We are going to use the specific heat capacity equation. Cp times Cp of what now, you might ask? Look, water. It's liquid water. So of course we're going to use specific heat capacity for water, not for the steam. So Cp times mass times change in the temperature. Okay, so Q3 is going to be what? 4,186 times 0.01 times what? Times the change in the temperature of the water. So 100 minus, we have what? Look, 153. It drops from 100 to 53. So we're going to say 100 minus 53. Okay, now this is going to be equal to what? Q3 is going to be equal to 1967.4 joule. This is our final heat. Okay, but is that it? No, I'm going to calculate all of them. So Q total is going to be Q1 plus Q2 plus Q3, and this is going to be what? This is going to be 663.33 joule plus 22,600 joule plus 1,967.4 joule, and then this is going to be equal to what? This is going to be equal to 2.52 times 10 to the power of 4 joule. This is what? This is the Q total. Okay, so this is it for today. In the next video we're going to solve practice 4C. Please, if you have any questions, you can comment below and I will be happy to respond to you. See you in the next video.